So, hi everybody. Welcome to this session on Kotlin development for the front end. So, to give you a little bit of context, I'm going to present myself and present the project I'm working on. So, my name is Gaetan Zoritchak. I come from France. I live near Geneva, where I usually work. And I've been working with Kotlin for a few years now, but essentially on the server part. And this year, at the beginning of the year, because of an unforeseen business event, I had to find another job. And I didn't want to go back on the market and code Java for banks, what you usually do in Geneva. So I look at what project I could work on where Kotlin would be an asset. So I was looking in the deep learning area when I discovered that there was no good data visualization library for the JVM. And I thought, oh, okay, what if we took the concept and the algorithm from D3.js and port them into Kotlin with the ability of using it in different platforms. So I discussed all that with my ex-colleagues, Pierre Mariac and Nicolas Badgeron, they are here. And they said, okay, it's nice ideas, we can work on that. And we started this project, which is called data2viz.io. And we've been working on that for a few months now. As we've been working essentially on the Kotlin.js part, it gave us the content for this presentation. So first, I'm going to show you what we are currently doing with this library, what we can do with this library. And so this is a kind of presentation we can do. This is a radial stacked bar chart. So the idea is to propose some appealing way of presenting data. Here we could imagine adding some animation of using the user interaction to make it more friendly. Here we have it's a procedural T-ring generation. So we can see that in games. The idea is to simulate the physical principle like rainfall and erosion. And here is, this is a demo. I'm going to relaunch that. The idea of this animation is that we have some random points that are on a sphere, and we are projecting them on a plan, and we are using that to test the implementation of our Voronoi algorithm. So it's a kind of global performance test. So all that is using Kotlin.js. Just to know a little bit more about you, I would like to ask you two questions. First, I would like to know from what kind of development you are coming, and if you know Kotlin. So, do you use Kotlin in production on the server side? Please raise your hands, the ones, okay. On the front end, sorry. Okay, you're already using Kotlin on front end? Okay. And on the desktop, is there anybody? Okay, a little bit. And on Android? A lot, okay. And the second question is, do you consider yourself as a front-end developer, a back-end developer, or a full-stack developer? So for the front-end, please, who's consider more front-end? Okay. Back-end and full-stack? Okay, it's my majority. Okay, thanks. So when you start a new project on a technology that is quite new, the first issue that you have is to find an efficient dev workflow. I mean, you have to do a lot of things. You need builds that are really working. You need to debug your code. You need to test it. You need to optimize when you are doing some JS development, you need to optimize the produced JS files. So that is what we are going to see more in practice, and we are going to share with you the choice we've made on these questions. So the first thing when you are targeting JavaScript platform is that it's more complicated than just back-end development, because you have your task you are running for your builds are half on the JVM part and half on the JS part. So for example, Kotlin.js is the process of the compilation. It's a JVM process, but dependency management is half of it is on the JVM and half of it is on the JS part. The test, you can have tests on both sides, and it's the same for all the tasks of your builds. So for example, you can have CSS preprocessing, you can use less Sass, and for that, usually you are going to use a JS task to manage it. So what tool are you going to use to handle all these tasks in a unified way? So this first question is quite easy to answer, and you have to use Gradle when you do Kotlin.js development. The first reason for that is the JetBrains team is releasing some of the new features only on Gradle for the moment. So for example, you have this new tool called this year dead code elimination tool that is only available on Gradle. It's not available on Maven. There is the new multi-platform things feature that is also only available on Gradle. It's not available on Maven. And we are waiting for this new feature, which is incremental compilation for Kotlin.js. And I read on Slack that it will also be available on Gradle first. So it's enough to make this choice of Gradle. The good thing is that it's really performant. I mean, there is all this daemon that keep in memory the information of your build. So when you relaunch your build, it's really fast. So it's a nice point. And also, it's easier to adapt to a complex build. And when you are doing JavaScript development, you have to use different tools that were not designed to work together. So at one moment, you are going to use the output of a task and use it at the input of the other task. But it's not at the same place, and you have to move it. So you have to copy your files from one place to another. And there, having the script with Groovy helps you to do this kind of modification of your builds. I see one little drawback is that Gradle is moving really fast. There are a lot of releases. And for example, the first 3.0 version was last year in August. And the first 4.0 was this year in June. So it's really short. And they are moving a lot of things. So sometimes it's difficult for the IDE to be completely synchronized with the new feature of Gradle. So for me, I prefer to keep an older version. So for the moment, I keep the version 3.5.1. And I think I will move on Gradle 4, maybe when it will be 4.4, or something like that. So when you have made the choice of Gradle, you have also another choice to do. Are you going to use the Kotlin Frontend plugin, which is the support is given by JetBrains. So it's a first option where you have the plugin Kotlin.js. You manage the plugin Kotlin.js like normally. But after, you can use this plugin that will handle a lot of JavaScript tasks, like managing the NPM dependencies, managing the execution of the test, the bundle of the application. So it's quite interesting, and it allows you to keep the configuration inside Gradle. You don't have to go inside each tools, and you just use your Gradle script to manage your parameter. And it can be interesting, but it's introducing a new dependency between your build and the task you are using. So sometimes, for example, Kotlin this year was released in August, but it has been available on the Kotlin Frontend plugin just for 2 or 3 weeks. So we have 2 months to wait before having it inside the Kotlin Frontend plugin. So for us, we didn't make that choice, and we preferred to say we are going to use Gradle for all the JVM tasks, and for all the JavaScript tasks, we are going to use the right tool and to be able to choose the tool we want to use. So it's a little bit more complicated because you must understand how each tool is working, and you are going to configure all tool with its own configuration file. But it's quite cool because you can change of tools, and if tomorrow or there is a new tool, the best JavaScript tool, you can change and be always up to date to the JavaScript ecosystem. So let's see how it's working. We are going to reuse the demonstration with the sphere, the Voronoi sphere, and we are going to see how it's working. So this is my code. I'm just looking if no, okay. So it's a small project that is using our library, and by default, you don't have to do a lot of configuration to do a Kotlin to JS compilation. So here I have the dependency of my project, so I'm using a lot of R code like color and stuff like that, the algorithm of Voronoi. And the only important parameter, I think, is this one, is the module kind of your project. So here, if you don't define it, by default, it's plain. It means that the dependency on the runtime are going to be stored in global variable in the JavaScript engine. So it can work, but really for small project or just prototyping. There is another option, which is AMD, so it's for asynchronous module definition. So this one is using the required JS library, and you are going to load the first script, JavaScript file, and it's going to use the definition of the dependency inside that file to load the other needed module files. So this is interesting in development mode because quite often you are going to create an HTML page, and you can, with that, have a quite fast build mode. So AMD is a good option, but there is another option, which is CommonJS. And CommonJS is used by a lot of tools. And during your build, some tools are going to rely on CommonJS for running their task. So we should have both. And this is this option, which is UMD, so it's Unified Module Definition. So it's working with both systems. So don't take too much time, just put this parameter, and you know that your code is going to work in both module definition type, AMD and CommonJS. So just to see if it's working. So here I'm just going to run the build without testing. So here I've just done a clean build, so it's quite fast because there is not a lot of code. And we are going to have a look on the project. So here I'm running with the required JS module definitions. So my first, the required JS file is loaded, and then my main JS file is loaded, and all the dependencies are loaded then using the definition inside each module. So we see here that we have kotlin.js, which is a big file, 1.5 megabytes, so it's quite a lot. And all the other files are quite small. And what is interesting is that the source is are really JavaScript code. So you can use this JavaScript code to do some debugging inside your Chrome tool. So here, for example, if I put a breakpoint here, my application is stopped, and I can have a look on the different variables. So here I have my points variable where it's the code is drawing some polygons, and I can see the points of the polygon. But it's not very easy to understand the code because, as you see, there is a lot of transformation from your initial Kotlin code to the JavaScript version. So here we have lambda of lambda of lambda of lambda of lambda. So to find where, if you want to look at something specific, it's going to be quite difficult to find it where it is in the JavaScript code. So hopefully we have another option, and so this option is working for quite a long time. It's Sourcemap, but there is an option that is available since the version 1.1.4, which is Sourcemap embed sources. And this is really interesting because during the compilation, the source map is going to be created, and all your Kotlin code is going to be embedded inside the source map. So it's a possibility of the source map specification. And so it makes the debugging really, really easy. I'm going to just relaunch the build. No, don't know what I did here. Okay. So I change the configuration, and now I reload my application. And now I see that I have the Kotlin source file. So I can do the same as before and say, okay, I'm just going to put here my breakpoint, and I have access to the same information with my points and all the currently drawn polygons. So this is a really nice feature, and again, don't take too much time thinking of it. Just use this configuration, and it will make your development easier. So this was the two first things to know on that part of the build. Now we are going to see the test. How do we do test in Kotlin? So it's quite similar to what you do in Kotlin or in Java. For the source part, you're just going to write your testing code like that. You are going to use a class, add annotations on your test functions, and during the compilation, the compiler is going to create some test suites, and these test suites are compatible with few JS frameworks. So it's compatible with Jest, Mocha, QUnit, Jasmine, and I think Tape. So depending after when you are going to run your code, it will, at runtime, it will use the correct framework depending on what is available on during the execution. So here it's just a quite simple test, but so the question is now, how do you launch your test? So I'm just going to show you the big picture, which seems to be quite complicated. But we said that we have a Gradle that is going to delegate the execution to some Node.js tasks. So here we have Gradle that say, okay, I'm going to launch a task that is defined in the package.json file. So, and this task is a Karma task, and Karma is configured with its own file, so karma.conf.js file. And here I say, okay, I'm going to launch Phantom.js to have this test being able to be run on Travis, for example. And then I decide what kind of testing framework I'm using. So I choose Mocha because the rendering results are quite interesting. So we are going to have a look at the different files. So here is my package JSON file. So we have now dev dependencies. So Karma, Chrome Launcher. I can use Chrome Launcher. I usually use it just locally if I want to make some local test. I have CommonJS, Mocha Reporter, and that's it. And here I defined my test script. So the test script is quite simple. It's just Karma start. And Karma start then is going to look to its own configuration file. So here we have the configuration file. So it indicates where are the test files. I indicate which browser I'm going to launch. And that's it. Here I define that I'm using CommonJS for the dependency because my JS file, my module file has some dependency. So I'm saying, okay, now you are going to use CommonJS to load all the dependencies. And so if I run that, so here I add the tests. And now we see that we have Karma that is launching the Phantom.js browser. And we see the result here. So here I have my two tests, and it's quite easy. So this is the first option to run some tests on Kotlin.js code. But we have another option. There is this new amazing feature of multi-platform. And multi-platform has been here for quite a long time, but just for the last two releases of 1.2, it's more official now. Even if it's experimental, it's official. It wasn't before. And it gave us an opportunity to move some code from pure Kotlin.js module to some shared module. And doing that, we are going to be able to test the code in shared modules using the JVM. So we are going to change a little bit our project. I'm going to switch the branch. Up. Okay, so now I changed. Now I have 3 modules. I still have my Voronoi Sphere JS module, but I also have a common module and a JVM module. So the idea is to move the code that was previously here in my there, and to move what I can in a common module. So here it's just an example. So I just move a data class. It's not really representative, but just to show you how it's working. So I just move this geo point in the common module, and I can now have in the JVM module, I can have some code, the code that was previously on the JS part. I have it now inside the JVM module. And so I'm going to rebuild my project. So the execution is still running all the tests. So the test on the JavaScript test, but also the JVM test. But what is really good now is that I can launch the test using here, for example, I can launch the test in debug mode. And now I have all the features of Kotlin debugging, and I can have my logging facilities and stuff like that. And it's much more productive and much more efficient to do that. So if you are doing some complicated stuff, okay, the JavaScript part is working well, but if you want to do debugging, it's better to do it inside from your IDE. You have some question? Don't hesitate to ask if you have. Okay, so the test, that is what we do. We use Karma and Mosha for the JS part, and when we can, we use multi-platform test. So now we are going to talk about the optimization of the code, because we saw that Kotlin.js was 1.5 megabytes. You can't release an application with such big files. So how can we optimize that? So we have this tool, which is dead code elimination tool, which came with version 1.14 in August, last August. So it's a really interesting tool that is going to analyze your code and to remove all that is not used. So for example, in the Kotlin.js file, there is a lot of things that you are actually not using. There are all kind of APIs, and you're probably only using a small part of it. So it's going to use your own code to, you define the entry point of your code, and then it's doing an analysis and to search for all the classes that are linked to your entry points. So this is quite simple to use. It's just, the idea is just to use this plugin. So you can say, okay, apply Kotlin this year JS plugin, and then I define my entry point. So this is my module name and the function that is the function that I'm launching in my HTML file. So that is the first thing, but there is another one. So that is just going to remove the unused code, but after you can still optimize a little bit better. So I have to change my configuration up. So here we just saw the execution of the Kotlin DCR, and then I use another optimization, which is I use Webpack. So with Webpack, I'm going to bundle all the JS file into one big file. But during that process, I'm also using Uglify, which is going to minify all the JavaScript code. So it's going to remove all the space, the tabulation, the comments, and it will also change the names of the variable, the names of the functions, to have a really small JS file. So here I see that at the end, my bundled JS file is just now 197 kilobytes. So that is the whole application. It's now that size. And if you apply some compression on your server, it's under 50 kilobytes. So now it's usable. So if I run the code, so now you see there is just one file that is loaded and with just that size. Okay, so now just so Webpack. So that is the idea. How do you release? Use this here, then use Webpack and apply uglification and compression, and you will have something that is usable. Feedback on Kotlin.js performances. So this is quite a complex subject because there are a lot of parameters that influence the performance of your application. And it depends on the JavaScript engine. Are you using Chrome? Are you using Firefox? The kind of code you have. So we didn't make some complete benchmarks, but however, we have done some comparison, and the code you see here, I have another version of it, which is using D3.js. So I said to you at the beginning that we were porting D3.js into Kotlin.js. So it's a way of testing our implementation against the pure JavaScript one. So I'm going to run this one. So it's exactly the same code. It's doing the same things. So we are adding points until when the frame rate is up to 40 frames per second, we are adding some points. So here you see that around 600 points, we are touching the limit of the 40 frames per second. And we've been quite surprised that the Kotlin.js version of it is only about 10% less performant than the pure D3.js version. So the code is, the algorithms are the same, but in one case it's a complete type code with using enums, using lists, and using all what you usually use with the type code. And on the other hand, it's a highly optimized JavaScript code. So the creator of D3.js is doing quite interesting stuff. But it's amazing that the difference is not so big. So it was a really good surprise. Yeah? I not have to shout.
So the D3 library is still JavaScript in both, right? It's the same library. You didn't port the entire library, it's just your utilization of it, or do you port the entire library to Kotlin?
Not yet. It's a big project. So for the moment, we are taking the lower part of the code and we are porting it into Kotlin. And we have, for the moment, maybe 95% of our code that is in shared module. So it's usable with Kotlin.js, but it's usable for other platforms. So it's usable for the JVM. But for the moment, when we compare that to what has been done in D3.js, I think we are maybe about 25 to 30% of the complete library of D3.js. But we are doing that, porting the element from D3.js to Kotlin.js. And the idea is we start to work on the lower level code, and before being able to design the APIs. And the idea is to have some higher level APIs, because when you are using D3.js code, it's quite difficult to use because it's a lot of chaining functions. You never know where you are. And having features, the features of Kotlin you can make really more nice APIs. So that is the ultimate goal. Another question? To summarize our experience on Kotlin and what we think of Kotlin on the front end, I'm just going to give you some thoughts. So for us, really the big strength of Kotlin for the front end is, the first one is multi-platform. The ability of having the same code running on a browser and running on Android can be really amazing. If you design correctly your application, you can imagine that a client application is going to be reusable, or part of it, maybe it can be 60% of it, can be reusable on different platforms. So for us, it's really important because we can imagine that some maybe people on the data science are going to use their own tools and building them on JavaFX, for example, and others are going to deploy their data visualization in a browser. The tooling is also really a good strength of Kotlin. If you have a really big project, having IntelliJ IDE, being able to manage the code and being able to refactor big amount of code is really nice. You don't have that currently on the JavaScript ecosystem. Also, some features of the language itself, like the DSL, can be a real asset for your project. So if your project needs maybe to help people working only with DSL, it can be a good choice to take Kotlin.js because you are going to prepare some DSL for them, and after they can be really efficient using only those DSL. So it can be a reason to use Kotlin on the front end. On the weaknesses, there are some weaknesses. One of them is the fact that the development process is still heavier than the JavaScript one. As you saw, you are using Gradle, but then you are using also other tools. So for people coming just from the front end, it can be more heavy. And if you are using TypeScript or just JavaScript and S6 and stuff like that, you will find that developing with Kotlin will be it would be a less light experience. There are some issues on the interoperability because when you are on the inside a JavaScript engine, you don't have list. You're just using arrays, kind of basic elements. So if you are using lists or maps or stuff like that in your Kotlin code, and you are going to and you want to work with other libraries, you have to do the transformation from your object to the object of the libraries. And when you're calling giving some parameters, or when you have to work with the result of other libraries. So the first one is more is just to say we have to pay attention on JetBrains focus, because JetBrains is doing so much work, and there is all this Android partnership with Google. There is this Kotlin native project. So they are working on so much things that maybe if there are not so much Kotlin.js developers, the priorities are not going to be handled as quickly than on other platforms. So it could be an issue. With the keynote this morning, they started with Kotlin.js, so it's not very accurate. But there is a problem for the moment that there is not really a Kotlin.js ecosystem. So we have a lack of libraries. We don't have for example, HTTP client libraries, or the serialization is not done yet. So it can be difficult for people to start a project on Kotlin.js when they say, okay, but I don't have anything. I just have a kind of low-level API, and how I'm going to handle my communication with the server and stuff like that. So this point should be addressed quite quickly to be able to people to use Kotlin.js. But it's also an opportunity. Someone who is wanting to work today on Kotlin can work on that and say, okay, I'm going to do the implementation on one library and do my part of the job, and it can be very interesting for the moment. And there is also the WebAssembly project that is really interesting. I mean, we can already work on code that is coded on Kotlin, and this code today is using JavaScript, but tomorrow it will be able to use the native function of the browsers and to be really performant, to provide really really amazing performance. So I think for the few next years it could be really an interesting project. So I think that it's the end of the presentation. Thank you for your attention, and you can follow us on the project. I don't have time now, but I can answer all the questions in the hallways. And okay, thanks.